Algebra 1, Lesson 9, Evaluating and Comparing Algebraic Expressions. Again, if this wasn't your least favorite class before now, this might push it over the edge. Any expression containing only numbers and operations is what we call a numeric expression. That's something like 3 plus 4 is a numeric expression. There's no variables in it. It's just a straight up math question. Right? Do we get that? So we can solve things numerically. We can even take an algebraic expression and make it numerical if we know what numbers we want to substitute in for our variables, right? We can take it and we can take an algebraic expression, plug in numbers, and now it's all numerical because it's all addition, subtraction, multiplication, division of just numbers. Right? And that's kind of the math that we would like to do. I mean, probably one of the number one complaints I hear about algebra is, I liked math up until they started throwing letters in it. Right, and that's when okay, well, those letters are just variables that represent numbers that we don't know what they are yet. Okay, so they're not anything super difficult, but people do struggle with them. And that brings us to our algebraic expressions. And that's where we're substituting in variables for numbers that are yet unknown or unfound. But we're still going to have addition, subtraction, multiplication, division, exponents, all those kinds of things. An algebraic expression can also be called a variable expression for obvious reasons. There's variables in it. There's an x, there's a y, there's an a, there's a b. Whatever it is that is in there, whatever the letter holds, is going to make it an algebraic expression. We might have several variables. We might have variables with exponents. We might divide by a variable or multiply by a variable. Okay? Two algebraic expressions that are equivalent if they simplify to the same value. Okay, if I can simplify two algebraic expressions to the same value, right? So I simplify two sides of an equation down, and let's say I get 2x plus 3 on either side. They both simplify to that, right? Which means essentially they're the same equation. If I canceled them out, I would have 0. Okay, that's what we talk about whenever we talk about equivalent expressions. And that's it. Those are the notes. Right? So what do you think we're going to do with the rest of our time? Let's work out some questions. Okay. We're going to work on our homework. That would be nice, wouldn't it? Okay. So let's look at some of these. All right, this 4n minus 4, is that numerical or algebraic? Algebraic. What would I have to do to make it numerical? Substitute 6n for n, right? So we can go ahead and do that. There's no simplifying the algebraic expression at this point. It won't simplify, so the only option I have is to substitute in 4 times 6 minus 4. Caden, what's 4 times 6? 24. Blayton, what's 24 minus 4? Okay, so we solved our algebraic to numerical expression and got 20. Okay, that's fairly easy, right? So far, so easy? Okay, very good. Okay, let's come down to question number 2. All right, can I simplify this expression? Yeah, I can. What do you mean I can't? Okay, so I have two options with something like this. I can either, 1, simplify the algebraic expression and then substitute in, or I can substitute in and solve it numerically. All right, a lot of people choose to solve it numerically. Solving numerically means I'm going to go ahead and put 5 in for n. I'm going to show you that either simplifying the algebraic and then substituting, or going ahead and substituting and solving it numerically will give me the same answer. Sometimes I struggle to speak. All right, so I think our first option, you guys said, go ahead and plug in 5, right? All right, so writing that down, we got 10 times 5 plus 6. Minus 8. What's the first step in here, Christian? 5 plus 6. We're going to do grouping symbols first, right? So we have 10 times what? 11 minus 8. What comes after that, Reagan? 10 times 11. Do our multiplication first. What's 10 times 11? Very good. 110. Then we do 110 minus 8, which is what, Anthony? 102. All right, is 102 an option? Yes, it is. All right, let's see what it looks like if we solve it algebraically. Will we still get 102? Okay, so we have our expression 10 times n plus 6 minus 8. If I was going to just simplify that expression, what would I need to do first? Mia? Can I simplify n plus 6? No, so I can't do anything with the grouping symbols. So what comes next? Blayton? Okay, what's the term for that? He said you have to multiply 10 times n and then 10 times 6. Do we have distributive property? Okay, so what is 10 times n? So I get 10n plus what? 60 minus 8. What's next, Tiffany? 60 minus 8. What's 60 minus 8? 52. Okay, now what do I do? Can I simplify that expression? No, but what can I do? Now can I substitute? 10 times 5 minus 52. What's next? Jordan. Which is? What's 50 minus, whoa, what have we done wrong here? No, oh, you're right. No, I did. Is that we got 52, but because of how I was thinking about it, I wrote it down as minus 52. It is plus 52, right? Plus 52, sorry. All right, so we got 50 plus 52, which is 102. Which one of those required fewer steps, actually? The first one took fewer steps. Second one took fewer steps. Okay. All right. You think the first one? Okay. Well, here's the thing. Does either one come up with the right answer? So does it really matter one way or the other? Okay. Not really. All right. There's probably a lot of you that are just going to solve it numerically. I'm going to substitute, and then I'm just going to solve like normal. All right. So I'm fairly confident. Let's see. Like for number 3, you're going to substitute in 14. So you're going to take 3.3 times 14 minus 4.2, right? Okay. You're going to do that. You come down here. You can't simplify that expression. Here's the thing that you need to be careful about. What are you taking to the fourth? 3. I'm taking 3 to the fourth. I'm not taking 15 to the fourth or 3 times 5 to the fourth, right? So I'm taking 3 to the fourth. What's that, 54? No, it's... No, it's bigger than that. I don't remember what 3 to the fourth is. 81. So you got 81 times 5 plus 5, right? So you'll get those types of things. I think you guys can handle that. You guys do have the answer key at the bottom to go ahead and check those answers. I want to get into something like a word problem, because those are the ones that kind of give us fits, okay, in terms of how do I take this information, put it into equation, go ahead and solve it, right? So if a water tank has a capacity of G gallons, we don't know how much it holds, so we just know that it holds G gallons, and it is drained at a constant rate of D gallons per hour. So we've got a rate, we know how much it holds, it drains at a certain rate per minute, gallons per minute. The polynomial G minus dt. So that's what's really handy here, is that they actually give me a formula. It can be used to determine the amount of water in the tank T minutes after it begins draining. So they give us a formula, G minus dt. How much water remains in a 3,800 gallon tank that has been draining at 132 gallons per minute for 9 minutes? So that seems like a really complicated question, right? Okay, that seems pretty tough. Okay. All right, so we have gallons minus our D, okay, which is our constant rate, okay, times our time. All right, so where do I plug things in at? Let's go ahead and determine what numbers we have. We have 9 minutes. What is 9 minutes going to be used for? What is minutes? Time. So I bet that that's going to go right there, right, for time. Okay, we have 132 gallons per minute. Okay, let's use a different color so we can kind of see some of this. Okay, does anybody know what that's used for? What variable? Does anybody know? It gives you the information in there. I heard G and I heard D. G, D. Why D? Constant rate of drain, D gallons per minute. Gallons per minute, right? We see that? All right, and what is, let's see, I see a 3,800 gallon tank. What is that? Your G gallons. Okay, so now that I've got all of that established, how do I write my equation? 3,800 minus 132 times 9. Okay? So what's the first thing you're going to do? What is 132 times 9? 1,188. Looks like that, right? Okay, very good. What's 3,800 minus 1,188? 2,612. See that right there? All right. That's our answer, 2,612. All right, so one of the skills that you need to have that's not just a math skill is being able to read a word problem and being able to determine, okay, this is the information that they're giving me, this is where I plug this back in at, okay? You might have to reread it 2 or 3 times to see that information, okay? Take your time. Okay. I want you to look through the remaining questions real quick and see which questions you would have trouble doing if you were all on your own. Okay, if this was my homework assignment, I did not have an answer key at the bottom, what questions might I struggle with? Okay, you see M in there? Okay, so you multiply. It's 3 times M times N. So in this case, it's 3 times 4. Okay? So I think you could do that. You got 4 plus 3 times 4 plus 3 times 3 times 4. Okay? You're good there? All these seem fairly easy. Any issues with like I'm just not doing anything there. What about this one down here where it's talking about comparing expressions? You're looking for less than, greater than, equal to. Any issues there? You want to see that worked out? Nope. Okay. All right. We'll go ahead and stop things right here. Give you guys an opportunity to get started on your homework.